Right. Uh, Today's session is on network analysis. In our last lecture on network analysis session, we discussed how to draw networks. We even discussed that network diagrams are the fundamental step of any project plan. So, uh, moving a little further, once you have done your network diagram, you have drawn your diagram, you are supposed to give a lot of information regarding your time estimates, right? So today's session will be on calculation of time estimates, and in your project diagram you are supposed to identify critical path, right? The meaning of critical path has been already discussed in the theoretical framework. So in this session we will take a practical problem and we'll try to answer the time estimates, and after calculating time estimates we'll identify the critical path. Now see, we have two kind of time estimates. One is called earliest time, one is called latest time. And critical path is a collection of critical activities. Now what is a critical activity? An activity will be called as critical only when the earliest time for the activity is equal to the latest time of the activity, right? With this information, let us start our problem. See, we have been given a project schedule in which activities have been given. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 activities. And for each activity, we have got 10 events rather. These are our events. Remember, in network diagram also we have seen this kind of information. One is an event, two is an event, and an activity is existing that connects one to two, but they have not given the name of the activity. So we are not required also. And for each activity, that means the activity which is connecting event 1 to event 2, that is taking 4 hours. Similarly, the activity which is connecting 1 to 3 is taking 1 hour. And likewise, for each activity, the time has been given. What we are supposed to do, we are supposed to construct a network diagram. Secondly, we are supposed to calculate earliest event time and latest event time. And finally, we need to determine the critical path and total project duration, right? So let's start with our solution. Great. Firstly, we need to draw the diagram. So we have to draw the starting event. So this is my starting event. And we know that we have been given the name of events. See, event 1, event 2, event 1, event 3, and 1, right? So from event 1, we are starting our project. Now see, from event 1, there is an activity which is connecting to event 2. So we'll draw an event 2. I'll reduce the size. Fine. Then I'll reduce this. So there exists an activity. There exists an activity from 1 to 2. I'm sorry, I need to edit this 1 to 2. See, from 1 to 2, so we have drawn an activity from 1 to 2 and it is taking 4 hours of time. Just a minute, I'll just adjust these things. So what we did is we we have an event which is our initial event, and we named it as first, as this is the first event as per the information also. Next, from starting event, there exists an activity which is connecting another event called 2. So we named it as 2, and we have we have connected 1 to 2. Now this is our activity, and this activity is taking 4 hours of time. So we have written 4, right? So don't mistake, 4 is not name here, 4 is the time spent, right, as time required. Now see, again, event 1 is connected to event 3. That means there should be another event 3, and event 3 is connected to, event 1 is connected to event 3, and this is taking time 1 hour. Now event 2 is connected to event 4. So event 2 is connected to event 4. Now this is taking, again this is an activity. This is an activity, and it is also taking 1 hour time. 3 is also connected to 4. So 3, there is an activity which is connecting event 3 to event 4, as it has been mentioned here. And this is taking 1 hour time. Fine. Now 3 to 5, that means there is another event 5. Another event 5, and event 3 is connected to, this is 5. Event 3 is connected to event 5, and it is taking 6 hours of time. Right? 4 is connected to 9. So 4 is connected to 9. I'm keeping here. Let us have this activity. So 4 is connected to 9. This is 9, right? And 4 to 9 is taking 5 hours of time. Then 5 is connected to 6. So another this thing, 5 is connected to 6. 5 is connected to 6. So the activity connects event 5 to event 6, and it is taking 4 hours of time. Four hours of time. Now 5 is also connected to an event called 7. That means there should be another event 7, which should be connected to 5 by an activity which is taking 8 hours of time. Fine? Good. Now 6 is connected to 8. So there should be an event. There should be an event called 8, and there exists an activity from there exists an activity from 6 to 8 and it is taking 1 hour's time, right? 7 to 8, we already have event 7 here and event 8 here. So there is an activity which is connecting event 7 to event 8. Seven to 8, right? It is taking 2 hours time. Then 8 to 10. So there is an event called 10, right? Now there is an activity which is from 8 to 10. So this is from 8 to 10, right? And it is taking 5 hours time. Finally, there is an activity which is connecting 9 to 10. So we have connected our 9 to 10, event 9 to event 10, right? And this is 7. So this is our network diagram. Now the first question was construct a network diagram. We'll go to the second part now, right? For second part, I'll just copy it here because I may require moving here and there. So we are supposed to see compute earliest event time and latest event time. So we are calculating earliest event time. Now earliest event time is denoted by EI. Now this I is in subscript. Right. So for each event we have to calculate our earliest time. We have to move up and down. See E1. Let me copy paste here. So E1 is the earliest time for the starting event, right? So it is always 0. Right? Second is RE2. Let me copy paste this. Second is RE2. Now see earliest time for event 2, right? So find out the path. 2 we can reach from 1 only. So it has to be E2 equals to E1 plus the traveling time between 1 and 2, right? So it is called Tij or it's called T12. So we know E1 is 0 plus, so it is 4, so our E2 is 4. Now E3. So let us see third event we can reach from 1. So it has to be E1 plus T13. It is E1 plus T13. So our E1 is 0 and T13 is 1. So it is E4. Let us go back to our diagram. Fourth event we can reach from second as well as we can reach from third. So there exists 2 ways. Whenever there are 2 ways, you have to choose maximum between see, if we are coming from 2, that means E2 plus T24. So it is E2 plus T24. Otherwise, if we travel from third, so it is E3 plus T34. So it is E3 plus T34, right? So your maximum between E2 is 4 plus T24. See, from here to T24 is 1. E3 is 1 plus 34 is 1. So 34 is 1, right? So it will be 5 plus 2, that means 5 is maximum. Let us go to E5. Just go to the diagram. See, fifth event can be reached from third event. So it is E3 plus T35. So it is E3 plus T35 equals to E3 is 1 and T35 is 6. So it is 7. Now E6. That means sixth event we can reach from 5. So it is E5 plus T56. E5 plus T56 equals to E5 is 7 plus T56, right, is 4. So it is 11. E7. Now seventh event, again we can reach from 5. So it is E5 plus T5 to 7. So it is E5 plus T57 equals to E5 is 7 plus T57 is 8. So it is 15. Next E8, right? Go to diagram again. 8. Again 8 can be reached from two different events. From 6 also you can reach, from 7 also you can reach. If we are reaching from 6, it is E6 plus T68. Or if we are reaching from 7, it is E7 plus T78. So we have to choose maximum between E6 plus T68 or E7 plus T78, right? So our E6 is 11. I'm sorry, is maximum between E6 is 11 plus 6 to 8 is 1. E7 is 15 plus 7 to 8 is 2, right? So 11 plus 1 is 12, 15 plus 2 is 17, so we'll go with 17. Next, E9 equals to, so let us go to our diagram again. E9, 9 can be reached from fourth event, so it is E4 plus T49. So our E4 is 5 plus 49 is 5 equals to 10. Lastly, it is E10, which is equals to we have to check 10. We are reaching again from two events. From 8 also we can reach, from 9 also. So it is maximum between E8 plus T8.10 or